Dr. Justin Davis has a master's degree in neuroscience and a PhD in neuromechanics, PhD if I can say it. Defining and building human brain fitness is one of his areas of expertise. He is on the team of a new brain game company called Noggins. It is my pleasure to welcome Dr. Justin Davis to Studio 4 to tell us more. Nice to meet you.
Nice to meet you too, Fanny. Thanks for having
Why do
us
I have a
today.
feeling you perhaps worked with Dr. Max Sinader at the Brain Research Lab, or did you?
Well, I didn't work directly with Dr. Sinader. He is the director of the Brain Research Center, so he has really important jobs like getting funding for new buildings, getting funding for new research, hiring the best from around the world to come and work here. So he does that sort of thing. I was a grad student, and I was the guy sort of boots on the ground getting the research done. So, yes.
So what interested you personally in neuromechanics and neuroscience? First of all, what's the difference between neuromechanics and neuroscience?
When I started out in the graduate program in neuroscience, I was doing a lot of wet bench work. So we used to work with little nematode worms, studying how they remember. Believe it or not, a very simple organism like that has a memory. So it was fun, but you're working late nights, you're working in a laboratory all by yourself, and I really wanted to work with people. So the opportunity came up to go over to the School of Human Kinetics and work with the neuromechanical group there, studying the neurophysiology of how we move and how we maintain our balance. So it's really a lot of fun to be able to work with humans 9 to 5, and you can go home at Christmas time and tell your parents I'm doing something that's a little bit more applicable rather than just poking around worms.
I'm not working with worms anymore.
No.
Maybe you can fish with worms,
Yeah, so
or something like that.
A little brain all the way to a big brain working with humans.
Now this store, this N-O-G-N-Z, that's how it's spelled.
That's how it's spelled, and it's pronounced Noggins.
Do you know when that dawned on me?
When?
About 3 weeks after I saw the store.
Yeah.
I thought, what is N-O-G-N-Z? I don't know.
Yeah.
It's like a vanity license plate or something, but I had no idea. Driving across the bridge one day, I thought, it's Noggins.
Noggins, that's right.
I know.
So it's a little bit of a brain twister in and of itself, so we thought it would be fun and cute, something that really is catching and would grab people's memory, that, you know, we're something new, something different.
And it's obviously why my brain doesn't twist all that fast, but eventually it caught up.
Yeah.
So tell me about the brain, the lobes of the brain, the different lobes of the brain, how they work.
Well,
That'll only take a few years, but
a few years. Well, what's
physical coordination, for instance.
Physical coordination is one of the parts of our brain that we really have functional domains for. So what we've learned about the brain over the last couple of years is a lot. We've learned a lot about neuroplasticity. We've learned a lot about the different parts of our brain that are responsible for doing different things for us. So we know that we have the front part of our brain, our frontal lobe, and that's really the part of our brain that makes our decisions. It plans and strategizes, allows us to do two things at the same time. It's really called our executive functions, which are our critical thinking skills. Then we also have a part of our brain, back in the back a little bit, called the parietal lobe, and it works together with our cerebellum to coordinate our movements so that we can make precise movements like reaching for my coffee cup or standing, maintaining my balance, and doing those sorts of things. So physical movement is really a parietal lobe and a cerebellar function. We also have our occipital lobe, and this is the part of our brain that creates our visual perception of the world. We used to think that we saw with our eyes, but what we've learned over the course of the last couple of years is that really our brain shapes our perception of what we see. Our eyeballs work like little cameras, and our brain puts together the picture for us.
So it's our focus, really.
Our focus.
If you had the privilege of watching the fireworks last night.
That's right.
Obviously, that part of your brain is working. But what else would have worked? So you're watching this magnificent display of fireworks and lights and color and all of that. Is that one lobe the only lobe ticking, or do they all work together all the time?
They're all working together all the time to allow us to achieve all of the things that we're doing simultaneously. So For instance, last night, while you're standing there at the fireworks, you have to maintain your balance, which is a very important process. You're also processing all of the visual information you see up in the air. So I don't know if you remember last night at the fireworks, but there were the ones that looked like little smiley faces when they went off.
Yes.
So that's one of those challenges for your occipital lobe, to be able to take all of those individual pieces of information that you're not really expecting to see a smiley face, but your brain can put that information together to make you have that memory.
Exactly, and then you have to remember to eat the cheese and crackers and drink the wine,
exactly.
too.
Can't forget that.
All of that.
All of that.
So that's, well, it's visual, it's perception. Two more, right?
Two more. So we have a part of our brain called our temporal lobe, and that's the area of our brain that's really responsible for processing auditory information as well as information about language that allows us to write, allows us to create speech and understand and communicate. So that's another important part of our brain that we can work out and exercise. And then finally, we have the areas of our brain that are responsible for memory. So memory is a really complex thing. We have many different types of memories for different sorts of things. Remembering a grocery list, for instance, is very different from remembering where you've parked your car or how you're going to navigate your way home from the mall. And memory really starts out in an area of our brain called the hippocampus, and it lives deep underneath our cerebral cortex. And it works with all of our different lobes in our cortex to form all of those different memories for things we see, things we smell, things we hear, all of the different processes that we go through.
So when a human is 80, 90 years old and
Right.
has an incredible memory, has not forgotten what they did at 6, also can do the New York Times crossword in ink.
That's right.
What's going on in that particular brain that's so good?
Well, one thing that we know about brains is that every brain's different. It's very difficult for anyone to say exactly why someone is really talented at a particular activity, like doing the New York Times crosswords, or has that picture-perfect memory at the age of 90. But what we do know is just because you're good at one thing doesn't mean you're necessarily going to be good at another thing. For instance, like I mentioned with memory, you could be very good at remembering long lists of things you got to get from the grocery store, phone numbers, and those sorts of things. But like I said, remembering where your car is something totally different. Figuring out how to navigate around a new mall or a new neighborhood can be a bit of a challenge. We can be really good at some things and really bad at other things. Well, I hesitate to say bad, but we can always
No,
improve.
but there, as you know, there are people who go someplace once and they know how to get there again.
That's right.
There are people like me.
Right.
Who can go someplace 10 times.
That's right.
And can't remember where I turned.
That's right.
I just find my way eventually.
And that's one of the fascinating things about the brain, is really how different it can be. So I really like to encourage people to pick up a book about the brain. So there's Dr. Norman Doidge. He's a researcher at the University of Toronto, and he wrote a great book called The Brain That Changes Itself. And it's all about neuroplasticity and how our brain changes over time and how we age. It also gives some great individual case studies about how the brain changes in the event of strokes or people with problems with balance and falling. So taking the time to learn about your brain is often a great way to help you use your brain better.
I was reading your factoids from Noggins,
Yes.
and apparently our brain is 60% or 60% fat.
60% fat, yeah, you really wouldn't expect that it's that fatty. But our brain is really composed of two types of cells. So there are the neurons, and they are the nuts and bolts of your brain. They're doing the work, talking to each other, communicating so that we can think, move, have a personality. But we also have these cells that make up the insulation that goes around our nerve fibers. And just like you have plastic around your iron cable that goes into the plug at home, you have insulation around all of your nerve fibers so that they don't short out. And that is fatty material called myelin. And we have a lot of it in there. So a lot of dense myelin.
A lot of myelin. When you get certain diseases, you don't have as much myelin, right? What
Right.
about like dementia, Alzheimer's? I know you're not a medical doctor, but...
No, but dementia and Alzheimer's is a little bit different. So what happens is you do actually lose those neurons, those important cells that are the nuts and bolts that are doing the work. And what happens is you can get these sticky plaques called beta amyloid plaques. You can get little tangles of fibers and proteins that really sort of kill all of
Sure.
those important cells. And it can happen throughout your cortex. So it can happen in the part of your brain that's responsible for memory, the part of your brain that's responsible for your personality. So that's why you can see sometimes some dramatic personality changes with people who are suffering
Right.
from Alzheimer's type dementias.
So what is brain fitness and how does it really work?
Brain fitness is a lifestyle, and that's really the take-home message. So what we've learned about the brain is that there's a lot of things that we can do to improve our brain health. And it all starts with proper nutrition. Our brain, it consumes 20 to 25% of all the energy we take in over the course of the day, despite the fact it only represents about 2% of our total body mass. So making sure our brain is getting all of the energy it needs is step one. Step two is really...
And when you say nutrition, you mean?
I mean healthy nutrition.
Healthy nutrition.
Don't go out and fill up
fruits
on,
and vegetables,
on Mars bars. Fruits and vegetables, as well as you can get fish. Well, fish is really good because of the omega-3 fatty acids that your body can't make itself. So when I say your brain's 60% fat, it needs those essential fatty acids, those omega-3s, to help build that myelin.
It makes sense. And then we have a few sins, as you know.
That's right.
Drink too much, smoke, things like that. Can't be good for the brain.
Can't be good for the brain, and it isn't, but we all have, you know, lives that we lead, and no one's a perfect angel. But there are things that you can continue to do if you're leading a brain-healthy lifestyle. So physical fitness, exercise, I really can't stress this enough. Of all the things that you can do for your brain, getting out there and getting engaged in cardiovascular exercises that are good for your heart and lungs is important so that you can pump all of that energy-rich and nutrient-rich blood up to your brain. And also, people who engage in exercise generally have a reduced risk of suffering from dementia in later life. And little laboratory rats that exercise also grow more new brain cells in their brain than those that don't. So exercise is really paramount to your brain health.
Is it a myth that we lose brain cells?
No, it's not a myth that we lose brain cells. We do lose brain cells. We're constantly losing brain cells through our process of development all the way through to old age. The myth was that we never grew any new brain cells. You're born with all the brain cells you're ever going to have, and you're just going to lose them over the course of your life. That's the big myth. We've learned that we are continually growing new brain cells in a part of our brain called the hippocampus, so that area that's really this sort of grand central station for our memory, which is neat to think about. It's one of those dogmatic things out there that we've kind of busted as a myth up in the research labs. And as I mentioned, physical fitness and exercise is one of the things that you can do to help you grow more new brain cells faster.
And weightlifting, does that help? Or are you talking about running, jogging, moving?
Running, jogging, moving, weightlifting is great too. Even exercises like ballroom dancing, getting out in your garden, going for a walk, anything that is really going to get you moving, engaged, coordinating movements using your brain that way, as well as exercising your heart and lungs.
Mind, body, a left-right, integrating left-right, is it important?
Yeah, so doing activities that require you to bimanually, so left and right, coordinate your movements is more of a challenge than doing something that's just a unilateral or a one-sided movement.
So if you're right-handed, try to write with your left hand.
Try to write with your left hand, do something different. Take a new route home from work. Take on a complex challenge like figuring out how to play the violin. So coordinating your left and your right hand to make that music is a real challenge, or even the guitar or the piano is great too.
At an early age, and if you do that at an early age, does it stick with you?
Well, what we encourage is
music?
Is a brain healthy lifestyle over the course of your whole life. So starting out at a very early age, the benefits that you're going to get over the course of your development from engaging in a difficult activity like that is something that might hold with you or might not, depending on what you continue to do.
So if you're 60 and you want to take up the guitar or the violin, it's a good thing.
It's a great thing.
Or piano lessons.
It's never too late. One thing that we've learned is that the brain continues to change over the course of our entire lives. And it's, you know, they say you can't teach an old dog new tricks. Well, when it comes to humans,
apparently
you can't teach old humans new
And
tricks.
they say learn languages.
Languages. And this really falls under the umbrella of challenging your brain with really complex and novel challenges. You want to avoid rote and passive activities. So if you're really good at doing crosswords, or if you're really good at doing Sudokus, that's great. But you're not really pushing your brain to that next level. You're not really testing your own boundaries. Something like learning a new language, picking up the guitar, or solving a puzzle or reading a book puzzle that you've never been able to solve before is really taking it to that next level.
So go to Bluegrass Camp.
Yeah.
Why not?
Why not?
Dr. Justin Davis, our guest. When we come back, we'll talk about the games.